Imagine a massive saturation strike in the Pacific, where hundreds of Chinese drones and missiles launch simultaneously today.
Instantly, the Ghost fleet detects the surge, triggering a localized microwave kill zone that drops the drone swarm.
High above, F-35s begin picking off the main missile wave with their advanced shield laser pods.
Destroyers unleash a hail of hypervelocity slugs at Mach 5, shredding what is left of the enemy attack. Any final leakers are vaporized by the HELIOS at 186,000 miles per second now.
A $500 million attack has been defeated for a front cost of less than $5 million.
The Navy won the battle and bankrupted the enemy without even turning on their main radar systems today.
We are exposing secret weapons that just turned the world's most feared missile into expensive scrap metal now.
If the carrier is the heart, then the SM-6 is its sharpened teeth, featuring a massive motor. This booster allows the missile to punch through the atmosphere to altitudes exceeding 110,000 feet.
It moves at hypersonic speeds to chase down targets like Chinese glide vehicles before they even enter dives.
Enter the Spy-6, which uses radar modular assemblies and individual cubes that act as independent radar units. It can detect a target with the cross-section of a golf ball from over 200 miles.
The system tracks 30 times more targets simultaneously than older versions, allowing management of a chaotic drone swarm. An F-35 can spot a target and hand off the firing solution to ships over horizon.
The destroyer launches the missile, and the F-35 guides it to the kill via data link.
In 2021, the world thought the Navy failed after shelving the electromagnetic railgun project entirely.
They pulled off a tactical pivot by stuffing the hypervelocity projectile into standard 5-inch powder naval guns.
A ship can carry over 600 HVP rounds, effectively turning every vessel into a hypersonic machine gun. Kinetic energy upon impact is equivalent to a freight train condensed into a tiny 2-inch point today.
The U.S. Navy is transforming the F-35 into a flying high-energy node, called the Sentinel.
This update provides 25 times more computing power than previous versions to run complex laser algorithms now.
The F-35 can now carry 6 internal air-to-air missiles, increasing its stealthy capacity significantly.
It utilizes the secretive black budget missile designed specifically to outrange Chinese systems for total maritime dominance today.
The F-35 carries the autonomous anti-ship missile with a 1,000-pound blast fragmentation warhead. You are not just fighting a jet. You are fighting at the speed of light in the Pacific. The HELIOS weapon system functions as a long-range sensor and a hard-kill weapon at sea now.
A single HELIOS shot costs exactly $1 in electricity, compared to millions for a defensive missile. Nuclear reactors on a Ford-class carrier pump out a staggering 300 megawatts of total electrical potential.
The carrier has an unlimited magazine. As long as the core is hot, the ammo never runs out.
The short-range beast is focused into a beam the size of a quarter to solve drones.
The pulsed energy projectile fires a megawatt-class pulse, lasting only a fraction of a second to fry.
This pulse creates a localized plasma burst and a shock wave equivalent to a flashbang at point blank. The Stingray stealth drone has fundamentally broken the carrier limitations by offloading 15,000 pounds of fuel mid-flight. China is betting on wingman concepts like the Sharp Sword to penetrate the carrier's outer defensive missile layers. Ghost Fleet Overlord autonomous ships act as forward-deployed sensor nodes and missile sponges for the carrier group.
The winner is the side with the most intelligent network sharing data across the fleet in milliseconds.
China launches a $5 million missile, but the US answers with $5 of laser and metal. Hit subscribe and we will keep showing you the tech that flips the battlefield before it even starts.
The industrial-scale production of hypervelocity projectiles ensures that the Navy maintains a massive magazine of kinetic ammunition. Tungsten is turned with extreme precision to ensure the dart remains stable while traveling at Mach 5 speeds. The motor housings for the SM-6 are forged to withstand the intense pressure of hypersonic flight vessels.
Carbon fiber weaving provides the strength and lightweight properties needed for missiles to reach over 100,000 feet. Gallium nitride modules are the heart of the Spy-6 radar, providing 30 times more sensitivity than before.
Managing the extreme heat generated by 150 kilowatt lasers requires advanced liquid cooling and thermal management.
Every missile undergoes a high-resolution X-ray scan to ensure there are zero defects in the motor.
The automation of the logistics chain allows for the rapid deployment of thousands of rounds to ships.
Titanium 3D printing allows for the creation of lightweight brackets that hold the laser pods on jets.
Massive electrical bus bars are installed to handle the 300 megawatt output of the Ford-class reactors. Internal weapons bays are cycled thousands of times to ensure they operate perfectly in the high-speed environment.
Calibrating the optical dazzler ensures it can precisely blind enemy satellites without damaging the ship's own sensors. Mixing solid rocket propellant is a highly controlled industrial process to ensure consistent thrust during the missile launch.
Circuit boards for hypersonic projectiles must survive thousands of Gs during the initial powder gun launch today.
Robotic carts move components autonomously throughout the factory to increase the production rate of advanced naval weapons.
Virtual reality design allows engineers to optimize the placement of microwave weapons on the Ghost Fleet ships. Forging engine components for the Stingray drone requires immense pressure to ensure the part can handle refueling.
The application of stealth coatings is a precise task to minimize the radar cross-section of autonomous aircraft. High-powered lasers cut through thick steel with incredible speed to build the world's largest aircraft carrier hulls.
Miles of fiber optic cable are installed to support the massive data requirements of the Aegis network. Testing the energy storage banks ensures that the laser can fire repeatedly, even without direct reactor power. Lenses for tracking systems are polished to sub-micron levels to hold a laser beam on missiles.
Automated foundries allow for the high-volume production of the Mk-40 55-inch naval guns.
The computer core for the Block 4 update requires a dust-free environment for maximum processing reliability. Drone landing gear is tested to withstand the brutal impacts of landing on a moving carrier deck.
Managing nuclear fuel assemblies is a critical task to provide the carrier with 50 years of power.
Testing microwave emitters ensures they can effectively fry drone electronics at a range of up to 5 miles.
Copper coils for pulsed energy weapons are machined with precision to create the necessary megawatt-class pulse.
Heat shielding is applied to ensure the missile's seeker survives the friction of Mach 5 stratospheric flight.
Hydrostatic testing ensures that autonomous underwater vehicles can operate reliably in the deep pressure of the Pacific. The production of tungsten darts is a high-volume process to ensure the Navy has enough ammo.
Installing the engine is the final step in the assembly of the Stingray stealth tanker drone today.
Forming the airframe of the F-35 requires immense pressure to create the necessary stealthy shapes.
Assembling laser diodes in a clean room ensures that the beam remains focused and powerful for use.
Robotic welding increases the speed and quality of the construction of modern naval destroyer superstructures today.
Virtual reality training.
Solid rocket motor testing ensures that naval missiles have the necessary thrust to reach hypersonic flight speeds. EMP hardening testing ensures that the ship's computer networks can survive a localized plasma burst from weapons.
Curing the composite wings of drones in industrial ovens provides the strength and lightweight properties for flight.
Testing the communication links of unmanned vessels ensures they can share data across the entire fleet cloud.
Pre-assembled hull sections are moved into place by massive cranes to speed up the destroyer construction.
Testing individual antenna elements ensures that the SPY-6 radar can precisely track and engage target swarms. Installing powerful cooling pumps is a critical step in maintaining the safety of the carrier's nuclear reactor. Anti-corrosion coatings protect critical propulsion components from the harsh saltwater environment of the Pacific Ocean today.
Inspecting laser lenses for any microscopic defects ensures the weapon can maintain a focused beam on missiles.
Massive quantities of raw powder are stored to support the high-volume 3D printing of advanced components. The flight control computer for an AUV is assembled in a clean room to ensure high reliability. The automation of missile logistics allows for the rapid deployment of air-to-air weapons to carriers. Gallium nitride modules provide the high power and sensitivity needed for the SPY-6 radar to operate. Titanium 3D printing allows for the creation of lightweight and strong brackets for the naval laser pods.
Electrical bus bars are installed to handle the 300 megawatt output of the modern Ford-class reactors.
Weapons bay doors are tested for thousands of cycles to ensure they operate perfectly in high-speed flight.
The combat cloud sharing data in milliseconds across the fleet is the key to achieving maritime dominance.
The computer core for the Block 4 update provides 25 times more processing power for lasers.
Robotic welding increases the speed and quality of the construction of modern naval destroyer superstructures in shipyards.
Rocket motor testing ensures that naval missiles have the necessary thrust to reach hypersonic stratospheric flight speeds.